All right, so sorry for keeping you waiting on these. I've had a bit to get through. Here we've got to maximise the shaded area, and we've got two little triangles that have been taken away. It's a little bit silly because it says the areas are unsuitable for planting crops, and then it says X is movable. But ignoring that and just going about the maths, well, the first thing we've got is the total area is going to be 40 by 40. So we've got a square, 40 metres by 40 metres. That's going to be 1,600 metres. But then we've got to take away, obviously, these remaining sections. Now, this little bit here is X. The remaining length on this side is 40 minus X, obviously 40 all the way across. If I take away X, what's left over is 40 minus X. So the total area is that. If I want the shaded area, so I'm just going to call it shaded area because they've called it A, so we'll leave it as A then. So it's going to be 40 by 40, and then I have to take away the triangles. So each triangle is a half of the base times the height. So the little triangle is a half of X by X, so a half X squared. And the other triangle is 1/2 of 40, so 40 there, and 40 minus X. And now what we're going to do is expand and simplify, and we should get to what they have. So we do that. Now I'm just going to go a half times 40. I'll do it in 2 steps just to make sure we stay on track. So a half times 40 is 20, and then we can do the next step. 20 by 40 is going to be 800, and a negative times negative will be a positive, so it's 20x. And we should find we have 1,600 minus 800 is 800 plus 20x minus 1/2 X squared. And there we have what we needed. Now it says find the area for which the value of X for which the area is a maximum. So if it's a calculator question, you can use a graphics calculator, you can do that. Otherwise, you've got to remember how to find the turning point. And the turning point for any quadratic, the X coordinate is negative B divided by 2A, and the Y coordinate 4AC minus B squared over 4A. You may not have seen that Y coordinate before, and it's not used very commonly because usually if people want to know what the maximum is, they just find the X coordinate, the turning point, and then substitute it in. If I'm going to use this negative B over 2A, though, I've got to write my area in a standard form. Remember our standard form of a quadratic, AX squared plus BX plus C. So I want to make sure I do it that way. So I've got negative 1/2 X squared plus 20X plus 800. And if I want to know the value of X for which the area is a maximum, therefore max when X equals, and I go negative B, so negative 20 divided by 2 times negative 1/2. And that's negative 20 divided by negative 1, so the answer is X equals 20. All right, I hope that helps. Cheers. So let's have a look at the next question here. Here we've got Q of X equals the square root of X minus 4. What is the domain? So the domain of a function are the values that make sense when you put it in. There's really 2 things we're looking at when you ask domain questions. One is that you're not going to divide by 0. The other is that we can't square root a negative number. So the domain, it's only going to work this function if what's under the square root sign, the X minus 4, is greater than or equal to 0. And that's all you have to do. If X minus 4 has to be greater than or equal to 0, let's simplify that. It will only work if X is greater than or equal to 4. That's what they mean by the domain. So the domain, what values are going to make sense for this? Well, only if X is 4 or bigger, because then I'll actually be able to find the square root. I won't be able to find the square root if it's a negative number. Find the slope of the tangent at X equals 13. So the slope of the tangent or the gradient, the instantaneous rate of change, all of those things mean the derivative. So we've got our Q of X, and we're just going to write X minus 4 using index notation because it's going to make it a little bit easier. So we're going to need a chain rule for this one because I've got something happening to the outside of the brackets and something happening inside, a composite function. If you have a composite function, we use the chain rule. So Q dash of X, and I do the derivative of the outside. So I just treat the bracket like it's a variable. So I go, put the power out the front, write my variable, and take 1 away from the power. And I just put what was inside that bracket just stays the same. And then I need to multiply by the derivative of the inside of the bracket. But in this case, the derivative of x is 1 and the derivative of -4 is 0. So I'm really only going to be multiplying by 1. So that's not going to change it. If I neaten this up, it's 1 divided by 2. The negative index means I can write it down the bottom. 1 over 2 square root of x minus 4. I can put it back in that form. So when x equals 13, q dash of 13 is going to equal 1 divided by 2 times the square root of 13 minus 4. 13 minus 4 is 9, square root of that is 3. 1 divided by 2 times 3, 1 over 6. That's going to be the slope of the tangent, the equation of the tangent. So part C, the equation of the tangent, we always need two things. One, we need the gradient, which we just found out. So q dash at 13, that was equal to 1/6, so that's great. And the other thing is we need a point on the line. And usually in this case, it's the point of contact. So it's when x equals 13. So what I need to do is not only have the derivative at 13, but also the value of the function at 13. So I substitute 13 in for x, 13 minus 4, that's going to be 9. So this is going to be 3. So now I've got point when x is 13, y equals 3. That's the other point on the line. And now we just substitute that into our straight line equation. We've got y equals mx plus c. So for this particular one, I'm going to have y equals 1/6 of x plus c. We substitute in the values we know. Sub in 13 and 3. Therefore, 3 equals 1/6 times 13 plus c. 3 equals 13 over 6 plus c. So I've got to subtract this from 3. 3 is 18/6. I take away 13 of them and I'm left with just 5/6. You can always use your calculator to check it. But once I've got the c value, I can now write the equation because I know the value of the gradient as well. So it's y equals 1/6 of x plus 5 over 6. That would be the equation of the tangent. Find the slope of the tangent at the point A where x equals a. So this is just doing the same thing except using a generic point now. So q dash of a, well, wherever they're used to. So remember q dash of x, we better double check what it was. I don't want to tell you the wrong thing. 1 over 2 multiplied by the square root of x minus 4. So it's going to be 1 over 2 times the square root of, and instead of x, I just write a minus 4. That's all we have to do for that one. Find the slope of the line from A to the origin. From A to the origin. Well, I'm not quite sure what they mean. Okay, well let's, yeah, so I think I've figured out what they mean. Q of A is, so when I put A into the original equation, I get, what was our original equation? Square root of x minus 4, so this is going to be the square root of a minus 4. So that means that there's a point at A and the square root of a minus 4 that's on that line. So if I want to find the gradient between there and the origin, it's a strange question, well, I've got the 2 points and I just use my gradient rule, which is the difference between the y coordinates, y2 minus y1 over x2 take x1. And we go ahead and we do that. So it's going to be the square root of a minus 4, take away 0 because y1 was 0, and then dividing that by a minus 0. We didn't really need those zeros, did we? And there we have it, the square root of a minus 4 divided by a, that would be the gradient of a line from the origin to the point A times the square root of a minus 4. Hence, find the point A on the curve such that the tangent passes through, and I haven't got the rest of the question there. So find the point where it passes through the origin, I assume is what it's going to continue on and say there. I have to find the point on the line where the tangent passes through the origin. So that basically I want the gradient that to equal q dash of x, and then I have to find x. Well, all we're going to do is find the point A again. It's going to be a little bit backwards. 1 over 2 root x minus 4. That's the gradient of a tangent. Find the point A on the curve such a tangent passes through the origin. So that would have to equal the square root of x minus 4 over x, and they want us to solve that. So that's a little bit confusingly worded, that question, but they're just basically trying to say, I want the gradient, which this is the gradient of the tangent, and I want it to equal this number for a particular value of x. So I have to just replace those a's with x's, so I've only got one variable. From here, multiply through by the common denominator. They're all the components of the denominator. So when I do that, I get rid of all those fractions straight away, and it's just going to make my life easier. So on the left-hand side, the 2 and the root x minus 4 are both going to cancel. I'm just going to have 1 times x is x. And on the right-hand side, the x cancels, and I've got 2 times the square root of x minus 4 times the square root of x minus 4. 2 times the square root of x minus 4 squared, which is, of course, just x minus 4, because of squaring the square root. We'll just undo what's happening to it. We're nearly there. X equals 2x, take 8. Add 8 to each side, subtract an x, and we've got x equals 8. So the point on the curve that has a tangent that will pass through the origin is the point where x equals 8. We can check that now by, we know that x equals 8, so what's the value of the derivative when x equals 8? And what's the value of the function when x equals 8? And we can actually put the tangent in and make sure we got it right. So the derivative, remember, all the way back up here, 1 over 2 times the square root of x minus 4. That's 1 divided by 2 times the square root of 8 minus 4, which is going to be 1 over, and 2 times 2 is 4, so that's a quarter. I'm going to put 8 into the actual equation. Remember, it's the square root of x minus 4. That's 8 minus 4. Square root of 8 minus 4 is the square root of 4, which is 2. So we should have y equals a gradient of 2. Oh, I've got the dash on both, and that's not right. The derivative was the first one. So the gradient is 1/4 x plus c. I now know the point that I'm looking at is 8, 2. So I sub in 8, 2. 2 equals 1/4 times 8 plus c. I'm pretty sure 1/4 of 8 is 2, and we got c equals 0. So we know we got it right. All right, I'll be back soon with the other questions. Good luck with your maths. Cheers.